Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 5.5, the last of our first semester, which is looking at comparing different types of functions. So the majority of this semester has been about looking at quadratic functions. So we're taking a step back and remembering what the difference is between linear, quadratic, and exponential functions, things that have been covered between this class and an Integrated Math 1. So to go over briefly, if you're looking at a graph, at the very least, you should be able to distinguish these three functions by now. Any linear function is going to have a straight line as its graph, and going up through the origin like so, that's the parent linear function, y equals x. If you are looking at an exponential function, remember that it has that curve with the asymptote, so something like this. And these can vary, of course, just like linear functions. You can alternate you can alter the slope. It can be going the opposite direction depending on what your leading coefficient is. But these types of curves, these are exponential functions. And then, of course, with quadratics, which is what we've been doing most recently, those are parabolic or U-shaped, like so. So just by looking at a graph on a function, you should be able to tell what type of function family it belongs to: linear, exponential, or quadratic. That's pretty straightforward. There are a couple questions in your assignment that'll also look at the equations of each of these. So remember, your linear equations typically are y equals mx plus b, written in standard form. The big thing we're looking for here, if it's a linear function, is that I do have an x, but I don't have an x squared. It's just a plain x. If I have an exponential function, I have y equals a times b to the x. So the exponent is my variable. And then if I have a quadratic, and this can be written in either standard, vertex, or factored form, but most commonly standard form is ax squared plus bx plus c. So there are a few questions on, let's say, the CASP test that will give you an equation and simply ask you to identify what function family it belongs to. So if it is linear, I have an x, but no exponent. If it is exponential, my x is the exponent. And if it is quadratic, then I have an x squared. X squared being the highest exponent indicates that it is a quadratic function. So you have a few questions on your assignment that'll simply give you equations and ask what type of function is it, and to justify your response. So if I have something like y equals 3x plus 6, for instance, I don't have an exponent as a variable. I don't have an x squared. Therefore, this would be a linear function. Y equals x squared minus 2x. The fact that it has an x squared indicates that it is a quadratic equation. The second that I see an x squared, and that's the highest that it goes, then it's a quadratic equation. And y equals 1/2 times 4 to the x plus 3. When the x is in the exponent, that means it's an exponential equation. So you're going to have a few questions like this that just simply ask you to identify what type of function is this based on the equation. Hopefully those are pretty straightforward. Again, if it just has an x, it's linear. If it has an x squared, it's quadratic. And if the x is the exponent, then it's exponential. The other thing you're going to be asked to do is to recognize what type of function it is based on a table. Now, this is a little more complex, but we've done this before in Integrated Math 1 and earlier in the year. So it could be written as a t-chart. It could be written as a list of coordinates, the same idea. But let's say I have for x, 1, 2, 3, 4, and my y is 2, 4, 6, 8. When you're looking at a table, you're looking for a pattern. What is the pattern between the numbers? So here, for instance, in this example, each time I'm going up by a factor of 2. Specifically, I'm adding 2. That's the pattern. So anytime you have a pattern of addition or subtraction, then it is going to be a linear function. So anytime you have a pattern of addition or subtraction, you're going to have a linear function. So the answer to this type of question would be linear. That's what type of function it is. If you have a pattern of multiplication, let's say again, just 1, 2, 3, 4, and we'll do something simple, 2, 4, 8, 16. Here there is a pattern also, but here I am multiplying by a factor of 2. So anytime you have a pattern of multiplication or division, then that is a exponential function. Okay. So you're looking for patterns of addition or subtraction for linear, or multiplication or division for exponential. Now quadratic's a little bit trickier. Let's take just plain x squared. So you have 0, 1, 2, 3, 4, etc. Now if I'm looking here, there's really not a pattern, right? I mean, there's no pattern of addition or multiplication or subtraction or division here. However, what we can identify in a table looking at quadratic functions is that, yes, there's no direct pattern here. This is +1, this is +3, this is +5, this is +7. However, if we look at a second pattern, taking that a step further, looking at these numbers here, this is increasing by 2 each time. So when you have the same second pattern that is the same, whether it's addition or subtraction, then that is considered a quadratic equation. So it's a little bit harder to identify. If you're looking at any given problem, I would start out and say, okay, is this addition or subtraction in the pattern? If it is, then it's linear. If not, see if it's multiplication or division. If it is, then it's exponential. If not, try to look at that second set of patterns and see if there is a common addition or subtraction factor that's being combined. That's all for this section. Have a good day, guys, and I will talk to you soon. Bye.